Welcome to our talk on Rise of the Machines. This is our sort of adventures in creating an automation framework in our organization. So you have make an AppSec great again. So my name is Rohini Sulatycki. I lead the assessment team at Dun & Bradstreet. Our team encompasses both AppSec, application security, and network security. We've also got Kevin Darcy, who's on my team, and Nick Raite. So little background on Dun & Bradstreet. So Dun & Bradstreet is a really old company as far as America goes, right? Not by European standards. So we can trace our roots back to 1841. We're one of the first companies to be publicly traded on the New York Stock Exchange. And we have a lot of data. So we sell a lot of data, we've got a lot of data, and we provide a lot of sort of, information to our customers about their data. Things like supplier risk, how much at risk is my supply chain? Or what do I know about my customers, and are my customers able to pay me, and things like that. So we've got a lot of systems, and we've got a lot of old systems, everything from mainframes and COBOL and everything very, very old to like very new systems like MongoDB, Hadoop, DynamoDB, every version of Java that can be imagined, classic ASP, so we've got everything. So, and the reason I'm talking about that is just to kind of explain, the challenges we have as far as security goes. So we've got a lot of very old applications, a lot of really new applications, things that are deployed to the cloud, and so on. And our job is to secure all of that. So, following the trend in IT, DNB outsourced a lot of the development. They had outsourced it, so there wasn't like any sort of consistent soft SDLC process. Things were developed on a project basis, following, whatever methodology or no methodology at all. And then recently we started insourcing everything, especially security. We insourced our security function. And it was about in 2015 is when this sort of team, came in its current format. We had sort of an application security assessment team. So, here we were, we've got this team, of people that we put together. We have all those apps that I talked about, really old apps, really new apps. We didn't even really know how many applications we had. Small team of 5 pen testers, and now 1 developer. We're getting more developers on our team. And we had a lot of other responsibilities, right? Like we have things like audits, requests for proposals, PCI compliance, SOX, updates, you get pulled into any incident that's out there. So that's sort of the landscape that, that we work in. So we've got all these, systems, networks, applications, all this other stuff. Anyone else in this situation? I figured there'd be people in the room who, who are kind of in the same situation. So what we started doing was we're a remote team. So, we've got a number of people in New Jersey. We've got people, in South Florida. We've got people in Dublin. So we work sort of remotely. And about a few times a year, we come together and have a summit. We all meet, we get together, we get into a room for about a week. And we try to figure out the challenges that we're having. What are the issues we're facing? What are the trends, sort of the vulnerability patterns? And how do we solve this problem? And, the thought that came to mind was, well, we kind of have to build an automation framework. We're never going to scale, right? We were never going to have a team large enough to meet this security challenge, to scan everything, to be able to protect this sort of hybrid, heterogeneous environment from all the vulnerabilities, all the hackers that are out there. That's just not going to be possible. So we understood we needed to build like an automation scanning framework. And that's kind of what we started to do, sort of like in 2016, we started putting together sort of the, the design for this automation framework that we were putting, that we knew we needed to build. So automation, right? This is a process where things operate automatically without human intervention, and it's kind of what we needed to do, right? We needed to be scanning. We needed to be, finding vulnerabilities before hackers did. And so that was kind of a roadmap. We knew we needed to do continuous scanning, right? We needed to be scanning our networks all the time. We need to be scanning our applications constantly. We needed to find these vulnerabilities. But we also knew that, given what was going on, we needed to integrate our tools into the development, pipeline, into the CI pipeline, right? We just weren't going to work. It wasn't going to work if we were going to do a pen test or, do something else. We kind of had to integrate our security tools and assessment tools into the CI, into the build pipeline. We understood that. And then we needed to find a way to protect our environment continuously, right? Because hackers never sleep, so we kind of had to go towards a model of continuous protection. So one of the first things that, we were getting asked for by people sitting in the room right now is for metrics, how many vulnerabilities do we have, right? How many of my applications are vulnerable to SQL injection? How many apps have critical vulnerabilities? What's the time to remediate those? So we're getting a lot of requests for these kind of metrics, right? Which are our top apps? Which are how many vulnerabilities do they have? How are we remediating those? So we needed to get metrics. We needed to build a lot of dashboards, before, not just for management, but even for the development teams, so they could start understanding and looking at the vulnerabilities there. And then, from my perspective, we needed to understand the vulnerability patterns, right? You're never going to fix everything. There's just too many vulnerabilities that, things happen all the time. Suddenly you'll have a 0-day show up, you'll never fix everything. But we needed to understand what were the big patterns, so, sort of the vulnerability patterns in our environment. Was it SQL injection? Was it uploading a web shells, weak passwords, no passwords, issues with patching? That's kind of what we needed to understand, so we could put resources behind that, right? That's where we would focus our energy on, and get sort of the most bang for our buck. We also had a sort of a diverse tool set. So, we had teams that were doing manual pen testing using Burp and SAP and, and so on. We were doing static scanning. We're using Fortify. We have third parties doing manual pen testing for us. We had vulnerability scanning using Tenable. So we had all these vulnerabilities coming out of diverse sort of tools that we needed to sort of aggregate. So, so like I said, a lot of penetration testing, a lot of scanning. And at that point, all this data was contained in PDFs or XML or JSON or whatever these tools would sort of spit out for us. So we didn't really have it in a central location where we could sort of mine that data and understand, what the vulnerabilities look like. So the first thing we looked at was creating a dashboard. So that was one of the first things we started looking at. We were already doing pen testing. We were doing, static scanning, dynamic scanning, manual pen testing. We were doing all of that. But really, we needed to get a dashboard. And so one of the first things, we looked at was using Elasticsearch, the ELK stack, right? So I was here in Dublin, and our performance team had just created a dashboard using the ELK stack. And I went down, looked at it, looked great. Went back and, talked to my team, and we started sort of looking at it, and it kind of it would work, but really wasn't the right solution for us. So that was one of the first things we kind of looked at, looked good, but didn't seem like the right fit for us. We thought about custom coding something like a dashboard, just creating sort of like a SQL or, NoSQL backend with a web application in front, taking all this data that was coming out of all these scanning tools and putting it in one place and creating dashboards from that. That didn't seem like a good idea either. We also took a look at Splunk. So maybe using Splunk and, putting everything in there and then creating dashboards from there. So Jira seemed, just at that point, we were becoming pretty heavy users of Jira. So our team actually uses the Scrum framework. We're an agile team, and we were ourselves becoming pretty like heavy duty users of Jira. And we were starting to put all our vulnerabilities into Jira. It made sense, right? That's where the developers were. It's the technology most development application developers use. They're used to using Jira. They're in Jira. They know how to, they know how to like close out tickets in Jira and so on. So that made sense that at least all the app vulnerabilities would go into Jira, right? That made a lot of sense. Jira also has great reporting dashboards. You can use Jira query language, JQL, and it's very simple to create dashboards out of Jira. So you can get things like, which vulnerabilities, which applications have vulnerabilities that are out of our SLA. Like say if you have a X period of time to remediate something, which vulnerabilities are not being remediated. So Jira actually does that really well. And you can use things like labels and, and owners and things like, assign issues to owners and all of that. So it made a lot of sense. And so that was sort of like the first sort of piece of the puzzle that fell into place, that like Jira needs to be our source of truth for all our vulnerabilities. Dashboards would come out of Jira, and metrics would come out of Jira. All reporting would be done out of Jira. So because Jira would contain, all our vulnerabilities, including our network vulnerabilities coming out of all our Nessus scanning that we did.
So once we got all the vulnerabilities into Jira, we were kind of in a good place at that stage where, we had a tracking mechanism. So then it was kind of, we needed to go back to where the start was, looking at, well, how are we getting all the information from our applications? So we started looking at, if we wanted to build an automation framework, well, first thing, where are we going to put it? It's got to live somewhere. It's not going to live under somebody's desk. And we had a couple of options here. So we had our traditional data center, which was a managed data center by a third party. We had just recently started deploying applications into the cloud, so that was also an option. And we also had a development lab in the office in Dublin. So that was something that we had, was quite physically close, and the team that were managed that environment were physically close. So, the considerations there, how cost, the traditional data center would have had a cost. We would have had to buy hardware. There would have been lead times, so we would have had to manage it ourselves. The speed of development probably would have been a little bit slower because we wouldn't have had as much access to it, because it's a much more managed and a much more locked down environment. So again, they were the considerations where the applicator or where the environment was physically going to sit. Jenkins, and my background was always in application development, and I joined the team in the end of 2015. So I was reasonably happy that Jenkins was probably the right tool to use for automation of jobs, because it was the job automation tool that all of the development teams use, and I was pretty familiar with it, so I was happy with that as a choice of a job management tool. And we did have other tools in-house at the time, so we were using Fortify on Demand, the cloud version, for doing our static scans, and it did also have a plugin for Jenkins at the time. But one of the issues that we knew it had was it didn't support proxy access out onto the internet. So that was a problem for us if we were going to have it in our in our data center or our lab environment. And we also had a preference for an on-premise solution at that stage. For the automatic or for the dynamic scans, we did initially take a look at Burp, which was probably our preferred dynamic scanning tool. It seemed to give better results. It was a much more user-friendly tool as well, but it didn't really lend itself well to automation at that stage. Nick actually worked quite a lot on that using the Carbonate plugin for Burp, but it still didn't really lend itself well to automation through Jenkins. Zap, on the other hand, was almost the other way around. It was very good for working with Jenkins. It did have a plugin that we could use out of the box, but we did find that it had issues with authenticated scans. So some of our applications have single sign-on solutions, which means it had to manage more than one cookie. So it was using the JSession ID cookie as well as the single sign-on cookie, and we noticed that Zap didn't always work very well with those. So the goal for the first iteration was really to try and get all our scan results in one place. So all the dynamic, all the static, all the third-party scans, try and have all those results collated into a single environment. The tools we looked at Jenkins, as I mentioned, ThreadFix was a tool that Rohini had discovered, I think, last year at AppSecEU, which could take all of the information sources that we need and collate them all in a single place. from Fortify on Demand. And then, as we mentioned, Jira was where ultimately we wanted the developers to look at the results. We didn't really want them looking at the unfiltered results because there was just going to be too many false positives in there. We wanted them to focus on just the issues that we had identified as issues in the applications that we wanted them to fix. And the environment we chose at that stage was the Dublin office test lab, purely because, well, mostly because I was working on this, and I was based out of the Dublin office, and I was sitting beside the team that managed the Dublin lab. So the results, so we did find that ThreadFix had some issues with FPRs, which came out of Fortify on Demand. So FPR is just their proprietary file format. And the issues there were, it was just reporting different bug counts. Now we did do a little bit of investigation into this. We worked with the ThreadFix team, and this issue doesn't appear to have been patched. Our alternative to that was to use CSVs coming out of Fortify on Demand, which means we would have gotten the bug counts that we wanted, but we would have lost some of the contextual information. So one of the nice things about Fortify on Demand was it actually showed you a snapshot of the code and highlighted the line where the exact problem was. We were going to lose that contextual information by going through the CSV route. And the other thing that it did very well was our third-party scanners, Sigil, did give us our results in XML format, which we could transform into a format that was consumable by ThreadFix. So that did look like a good route for us. So, but the learnings that we did have, the lab was just the wrong environment for where the applications were hosted. As the name suggests, it's a lab environment. It doesn't have full access to the rest of the D&B network. And what was worse is the rest of the D&B network didn't really have access to the lab. So like the guys in the US didn't really have direct access to it. You know, that didn't become immediately apparent because I was kind of working in isolation, and it wasn't until we started trying to expand that out we discovered those problems. Despite its issues, ThreadFix actually did look like a good candidate for, you know, the repository for all of our information. But what we did the big mistake that we made in this phase was we're probably just trying to do too much too quickly, trying to get everything into the one place in one massive step. It's kind of like going from nothing to everything in one step, and it was just probably going a little bit too much too quickly and being a bit over ambitious. So what we tried to do then was try and, you know, we were an agile team. We work in sprints. We went for a second iteration and just shifted our goals slightly. So the main goal was just to get out of the environment that we were in, because we knew that was the wrong environment. So we did have a DevOps team also based in the Dublin office. So we started collaborating quite closely with that team. And they were very good at getting us, you know, spinning us up EC2 instances and giving us access to those instances. So it was almost a like-for-like swap for the environment that we had. We kind of expanded the toolset a little bit, in that Jenkins was still there, ThreadFix was still there, Jira was still there. We did swap out Fortify on Demand, the cloud instance, for the on-premise solution. So that was, again, almost a like-for-like swap. And we introduced another app called Bag of Holdings, which Rohini will talk about in a second, just to act as an app repository. And the environment that we chose was the development AWS account managed from the Dublin office.
So Bag of Holding was an application I learned about last year in Rome at AppSecEU. Was you know, number of teams were talking about Bag of Holding, and at that point we did not have an application repository. So say somebody was to ask about you know, how many apps are running Java 6 or something like that, we really couldn't tell you. You know, we had that information in different locations, but it wasn't something we could really say, get reports on. So, you know, went back, installed Bag of Holding, you know, which turned out to be a great app. It's a Python Django based app, open source, you know, which is a big deal for us. We don't have a lot of money, right? We've got to use all the free tools we can get, and it's great that people are out there developing these tools. You know, we started to put, you know, our applications in there. So this is sort of like a test application, you know, just DBWA that I've actually put in there. It's kind of what it looks like. So you can actually put in things like an overview of the application. You can add all the technologies in there. You can add custom field things like regulations. So for example, PCI compliance, right? Like if that's something that applies to your application, then you can add that in there. You can do a bunch of, you know, things like business criticality and so on. If you look at the tabs up there, there's, you know, things like engagement, you know, so engagement there. So that actually is where we put in all the information about the security testing that's being done for this application. And interestingly, it's something that our security operations center now uses. So anytime they have an incident, or they actually log in a bag of holding, and they can find out, when was the last sort of pen test, or, any kind of security testing done on the application. And they can even get a link to the report in some cases. So that's really great. We also have things like the people, if you look at that, that's the owners, like who's the development owner, who's the business owner. So if you want to get a hold of people, like who your contacts are, all that's in there. So this app turned out to be a really successful thing for us.
So just on the results of iteration 2. So again, similar to the lab environment, we found that AWS was a good environment for us to get set up and deployed to. Again, we got root access to all the environments that we needed, which realistically you do need if you're going to be doing the deployment and management of tools. It had really good access to the external network, being a cloud deployment, so we had full access to our external facing network. We could scan those quite easily. But on the downside was that the AWS account that we were in wasn't really the correct one. So we had 2 separate accounts with AWS at the time. The development one was, as it sounds, I said it was kind of ring fenced from the rest of the network. So as it turns out, our Jira instance was actually installed in our other cloud environment. So one didn't really talk directly to the other. There was a possibility of doing a network hack from one to the other, but we really didn't want to go down that route since we were the security team. So that was, again, probably one of the mistakes that we made, was just kind of rushing into the wrong account. Bag of holdings definitely worked for us, as Rohini said. It started off just being something that we were using within our own team, of just doing simple things, logging the applications, logging credentials that we were testing with, the URLs that we tested with, the engagements that we had. That it was a really good application for logging all that information and externalizing it to other teams who needed access to it. One of my own personal learnings was, I don't know if anybody's familiar with AWS, but don't ever use spot instances for this kind of stuff. This was sold to me as a cost-saving way of running in AWS. It's a cost-saving way. It surely is. It's also a way to lose your EC2 instance very suddenly and very spectacularly, which leads me on to the next point, which is make sure you document everything that you do. So our static scanner was actually set up on a spot instance, which vanished without any documentation trail either. So we had to go through the process of rebuilding that environment. It wasn't a total loss because we were going to have to move it anyway, but I would have rather to do it in a controlled fashion rather than having the rug pulled from underneath me. So that leads us on to kind of really where we are today, which is iteration 3. So again, the big goal here was just to get into the correct AWS environments. What we started to do again is kind of being a little bit more focused on what we were trying to do as well. So in the previous environment, we still had the dynamic scans in scope, which was kind of distracting us a little bit. So in the iteration 3, we said, look, let's just forget about the dynamic scans. Let's just get one type of scan up and running. Let's get it running well. Once we've got that done, let's move on to do something else. So we stuck with Jenkins and Jira and HPSCA, which we had learned a lot about in the first iteration. Bag of holdings was still in there. And we had another new tool called VulnReport, which again Rohini will talk about in a second. And we had just started using Slack internally in D&B, so that looked like a good mechanism for sending out alerts and tracking things rather than just using the traditional emails. As I said, the environment was just the hybrid cloud managed from the US.
So VulnReport was something we added, like Kevin said, in the latest iteration. This is another open source report that's created by Salesforce. It's a Ruby on Rails. It's got a Postgres backend. You can also use MySQL. So we're still creating a lot of reports, even though while our vulnerabilities are in Jira. And I think maybe our end goal is to actually generate reports out of Jira. So but there's a lot of people who don't log in a Jira. For example, your senior management, developers will log in a Jira, PMs might, but a lot of people who actually need to see a penetration test report or some report on security testing may or may not log in a Jira. So we were still creating a lot of Word documents. It took us quite a while, it took us several hours to create these Word docs, which would go through QA and so on. We installed VulnReport again, and you can create templates and so on. So here's sort of what it looks like. You can create templates in VulnReport. It's got a bunch of pre-packaged templates. You can create custom templates. You can also do workflow, so you can actually do QA through it. It's really fast. So it brought down our time from creating a report from say like several hours to 30 minutes. which was a great win for us. Saved us a lot of time.
I would say several hours is optimistic. It was usually several days. Anyone who's written reports will know how painful they are. So the results of iteration 3, and again, this is really where we are today. So we were finally in the correct AWS environment, which was really good. The static scanning environment that we ended up building, and I'll show you kind of a network map on how that works in a second, worked really, really well. So we ramped up from pretty much 0 apps to about 50 apps in about 4 months, which was great. And Bag of Holdings really helped there because it was in a repository for information. We had all of our source code information, like, where it was stored, how to get at it was already there. So that was a great way to get access to that information. One slight limitation was that it didn't have, full access to the entire network. There was a firewall sitting between the two. So it really only has SSH or HTTPS access, which is fine for pulling code, but we knew at some point further down the line that was probably going to be a problem. And we made sure that we stabilized and secured our own tool sets. So, we did carry out our standard scans on our own tools. So we weren't just, we were living by our own rules. We weren't just saying to the other teams, you've got to secure your apps. We were making sure we were doing the same with our own. So the learnings, again, admin access to your EC2 instances or your Linux boxes is pretty much crucial to velocity. If you don't have root access or you have to go through a team, if you've got to raise tickets, it's just going to slow you down. The downside of doing that is, you break it, you bought it. And we've been in that situation a couple of times where, because we have that level of access, we have to be comfortable with managing those environments ourselves. Integration with single sign-on is useful, but not really important. So some of the tools that we have do integrate with our Active Directory server, which is really good for, quickly throwing out accounts to people if they need access to something. But it's by no means a blocker. It'd be great if everything had it, but not everything has it. So the likes of Vulnreport and Bag of Holdings don't integrate into our AD server. But, we can manage it because there's only a small user base for that. Snapshot instances before you make changes. Again, this was a learning that I had, and I was discussing this with one of the members of the Defect Dojo team this morning. I tried to put 2 Django apps on the same server, which was a huge mistake, and it took me a while to undo those changes, but thankfully that's back up and running. And one of the really important points is, give the development teams access to the results of your scans, as much of the information as you can. If you're trying to filter it down into a one-liner of, there's SQL injection and this is the line of code that it's on, that's not really enough for them. And the tools are really good with giving them kind of that contextual information. So give them as much information as you can. And probably one of the key learnings again is grow the environment incrementally rather than trying to do too much too soon. So taking, a lot of small steps very quickly is much better than trying to take one large step, which, can and often does go wrong. So just to give you an idea of what the static scanning tool looks like. So this is a screenshot from HP Software Security Center. So again, we've just carried out a template scan on DVWA. So it's nice because it does break things down into categories. So, command injection, cookie security, categories that we can filter down on pretty quickly. So we try and break things down into 3 distinct categories. False positives, which we just don't want the development team to really look at all. Then there's stuff like bad coding practice. So the likes of, dead code or badly named variables. Again, strictly speaking, stuff that's not really a security problem. It's just bad coding practice, the kind of stuff that Sonar would find. We generally don't create JIRA tickets on that because that's the stuff that, the development teams can fix in their own time. We don't hide it from them either. That information is there, but we don't police it. And then the last category is the stuff that's kind of exploitable or potentially exploitable. So because my background's in application development, I can make a reasonable guess from a source code as to whether something's wrong or not. So you can see, for example, there, that one's, I think it's weak cryptography, and you can see straight away they're using MD5. So that's kind of a no-no. So that's an easy one to point out, and the scanning tool is really good at finding out those things. But there are some things that it's not so good at. So we try and filter that information as much as possible before we give it to the development team, but we don't hide it from them either. So the information is always there. So just an overview of our current environment. So Jenkins is, the one that rules the roost. It's where all the scans are managed from, run from, and deployed to. What we've tried to do is use Bitbucket as much as possible, both for retrieving the source code for applications, and also all of our Jenkins jobs for the scans are stored in Bitbucket. So at the time we were working quite closely with the DevOps team, And they told us about Jenkins pipelining, which basically means you can have your entire Jenkins configuration in your source code repository rather than having the traditional kind of GUI driven jobs in Jenkins. So we went down that pretty quickly, which worked well for us. And then we decided to use Slack as our monitoring mechanism. So, when a scan starts, when it finishes, if it fails, if something goes wrong, we can just send a message out to the Slack channel. And it's an easy way for us to monitor it because, we can get it on our desktops, we can get it on our phones. We're not, it's not just churning out emails.
Show a demo of it in a second.
Yeah, so there is a demo of that in a second. So as I said, Bitbucket is used for retrieving both our jobs and our source code, and that's kicked off from Jenkins. That's pushed to Fortify SCA, which is our scanning box. And Jenkins also polls for the results to make sure that the scan's complete. And there's also a timeout in there. So if the scans are taking longer than expected, the scan will time out. And again, it'll send an error to Slack, just giving us a warning on that. And then the results are sent to the Software Security Center, as I showed you earlier on. Then we go through our review process, and then we push those results from Software Security Center into Jira. And also what we do from the vulnerable report is for the dynamic scans, for now, we're just manually creating the results in Jira, although we have a plan to address that, which would be iteration 4. So this is where we're going with our next release, which is basically to pull the dynamic scanning into our automation framework. So we'll probably start with something simple, unauthenticated scans. That should be pretty easy to get up and running. We do have the ZAP authentication issues that we want to look at, and we were actually doing the training earlier this week for the SecDevOps training, which we got some good ideas out of, primarily using Python to drive the scans rather than trying to do everything through Jenkins. And then choose a repository tool for the dynamic scans. So we've looked at ThreadFix, and we've also been looking at Defect Dojo. If you note the front of the laptop, you'll probably get that. So we're not sure which one we're going to use yet, so we'll probably just do a bake-off between the two. And then what we want to do is gain access to the internal network by having Jenkins slaves on the internal network that are managed from the master in AWS. And also one of our plans is to start build integrations. So instead of the scans running kind of separately to what the developers are using, integrate it directly into their continuous integration pipeline. So this is pretty much what we have today. And so what we're trying to get to is have the Jenkins slaves sitting on the internal environment, which will give us access to the other repositories that we can't access, which is the likes of Subversion and Serena Dimensions. We're going to start introducing ZAP as our dynamic scanning tool. And then, as I said, have a bake-off between ThreadFix and Defect Dojo. We're not sure which one, as I said, at this stage, to be the recipient of the dynamic results. What we'll do there is the same as we do in the Software Security Center, which is, review the scan results, weed out the false positives, and then put the results that we're happy with into Jira. And then also our team is also involved in managing Nessus. So we want to try and get the results of those scans, or actually we are already pushing the results of those scans into Jira. We may end up pushing them through Defect Dojo or ThreadFix yet. So we're not quite sure yet. So there's still some unknowns in there, but I think we're happy with the unknowns and that we can solve them as we go along.
Okay, so, one of the issues we're obviously facing is the volume of issues that are being found. When you start doing automation, you're going to start getting a lot of issues. So what are you going to do about that? So what we're trying to do is taking a, gamification approach. And this is something we've just started. We're trying to basically validating issues that are found through, say, Nessus. We all get together. We have a game session like on a Thursday. And, we try to make sure that we all get together and we see if it's exploitable. Maybe there's a exploit for it or something. We actually just quickly do quick checks, see which one's exploitable, which ones need to be handled right away. We're doing the same thing with remediations. We divide up, we have like a game session. We're thinking of handing out like prizes and things like that. So something we're just trying. We can talk more about it after we've done this for a while. So lessons learned. Iterations are good. Being agile is good. Failing fast is good. As you've seen, we did a few things. Some of them worked out, some didn't. But because we were agile, we were able to sort of move on to the next iteration. It's a good thing to take an iterative approach. Choose your tools carefully, but don't be afraid to experiment. I heard about a couple of tools last year here in AppSecEU, in Rome, and as you saw, we went back and installed them. We're using them now, so that's great. Open source, obviously, great thing. Big supporter. One of the things is have a good relationship with your engineering and ops teams. If you're going to do automation, you're going to need their support, and you will need their input, and you'll need their help. But then they'll need to work on that automation with you. So have a good relationship with them. And then finally, the mandatory like Titanic reference, right? Watch for icebergs ahead. Have your goal in mind, know what you're doing with build integration, but, but don't let, things derail you. Like you're doing that for a reason. If you have a strategy and things, make sure you follow through. And now we're going to have a quick demo.
This is where the demo always goes wrong.
Okay. So hello, everyone. So what Rohini and Kev have done so far is kind of bring you through the journey of how, why, and what. And so far, I'll just show you a quick what it is today and how it stands. So as Kevin mentioned before, we're relying pretty heavily on Jenkins. Okay. We're relying pretty heavily on Jenkins. And we staged it out in a few different ways. That way, if there is any issues while we're developing it, we can tackle them early on. So here's just a quick piece of a little bit of the code we're doing right now. As Kevin mentioned before, we do store all our commands in Git, just in case if there is a problem with Jenkins. It's all in Git. We all have it. We don't lose anything. So in the highlighted piece here, we have the current app name and app version we're currently using to scan. We also set the timeout version. Timeout is for if we do run into any issues, it'll alert the team in Slack. So in the setup stage, it'll pull further instructions from Git and message the team from message Slack. It should come up any second now. Yep.
Yes.
So the team will get the message in Slack saying that the scan started, everything's good to go, it's going. So moving on, what will now happen is we'll check out the code from the dev team's Git repository, we'll zip it up and get some further instructions ready and send it over to the scan stage. So what the scan stage will do is Jenkins will take the code, move it over to the SCA server, which will then start off the scan. Continually pull it until the timeout is reached. If it completes, it'll let us know that the scan is done. If the scan times out, it will then let us know that the scan is timed out. Maybe there was an issue ran, it's taking longer than expected. We should take a look at it. Moving forward, once the scan is done, it'll upload the results to SCA and then clear the results. So as you can see here, Jenkins let us know that the scan is completed. And then moving forward again, here's just DVWA results in SSC. So from here, we can take a look at the results and begin auditing the results and start taking a look at specific issues, determining which bucket do we want to put that in. Is that something that needs to be looked at and addressed, or is it something we can, false positive, just kind of don't worry about it. And then from there, we can then push it to Jira, provide information such as where it is in the file, a link back to SSC in case developers want even more information than is provided here. But as you can see, there's some examples and recommendation on how to fix it provided in Jira itself.
So I think that is actually the end of the talk. So that's just a quick run through of our environment and where we've gotten. We're hoping to come back next year and tell you, the advancements that we've made, including in the dynamic scanning, the results of our bake-off between ThreadFix and Defect Dojo, and hopefully more successes. So as I said, hopefully you found that talk enjoyable and informative, more than enjoyable. And we'd like to throw it open to questions. Thank you.
Any questions, folks?
Which is more of a GRC type tool, and obviously for vulnerability management, not everything's going to get fixed in one release. I'm just curious how that's worked out for you.
So yes, I think, if you listen to the keynote talk this morning, they talked about friction. So we chose the path of least resistance, and we wanted to go with what they were already using. Instead of having them use different dashboards, new tools, we decided to go where our audience was already at.
Thank you.
First off, great talk.
Thank you.
So thumbs up. I have two questions. One is, as I understood, the integration was mostly driven by the availability of tools. Would you do it, like, if you would do it again, would you choose the same strategy?
Yes and no. I think the tools that the development teams already use, I think that was a natural fit. I think what we found initially was when we were giving the likes of the reports to the development teams, they didn't get it. They didn't read it. All they wanted was an environment that they were used to. Like one of the pieces of feedback that we had was, when we were using like the IDE integrations for doing source code scanning, they didn't really like that either. Yeah. They wanted all their information in an environment that they were already used to. So I think using the tools that the development teams were already using was, I'd love to say it was something that we planned and knew would work, but we kind of just guessed at it and it just happened to be the right result. So Jenkins and Jira, I think, were, just happy choices that happened to be the right choices. The environments was probably the one that we struggled with a little bit at the start. So I think we're now in the right environment. I know because I've got a background in application development, I always had a preference towards the more open source tools. I think for doing the static scanning, that's something that's not easy to do. It's not something that, and without having a dedicated team and an open source project, it's going to be a good open source tool to find. So that's one, where the commercials probably do have a little bit of an advantage over the open source tools. But for scanning tools, we don't have a plan to go down a commercial route at this point. So I think we're happy to, pick a tool, invest a little bit of time in it. If it doesn't work, we'll replace it with a different tool. If it does work, we'll keep it. And so I think that incremental approach has worked for us. But I don't think we pick a tool and bet everything on it.
Yeah, and I think, we may we're looking at Zap right now for the dynamic scanning. We may, if Burp comes out with like a CI integration, we may look at it as well. So I think we're open to changing and using the best solution.
I meant rather that, like, if you consider another strategy, like you pinpoint the most important applications you have, and then you try to fit the tools to actually scan those applications, or you try to find the vulnerabilities that are most important to you, and then try to find the scanner or whatever tool that finds those vulnerabilities.
So that's probably more of an approach that we're looking at from a web application firewall perspective, but from a scanning and vulnerability identification, what we're finding is the scanning tools that we're finding pretty much they're finding everything we need. So like one of the good comparisons that we have is Cigital, who do our third-party scanning. We're able to take their reports, run our own scans and make sure that, we're finding what they're finding. And more often than not, we're finding more than they are. So, I think from a scanning tool perspective, I think we're pretty comfortable with what we have.
Just one more quick question, sorry. Do you actually, but probably that answers my question, but do you also develop your own tools? And what's the percentage of...
Yeah, we've actually written our own tools as well.
So we've done a bit of customization on Zap, which we're used to basically just blanketly scan our external network, kind of like Nessus. Right. So that's been quite successful as well. So one of the gaps that we don't have is, mapping IP addresses to actual applications. So again, that's something that we haven't figured out yet, but it's something that Bag of Holdings is helping with, but it doesn't fully address it.
That's something we're actually finding on the team, is that there's a fair amount of development and in like the glue that needs to happen that's being done on the team at this point. So.
Thanks, folks.
All right, thank you very much.
Great, thank you.